welcome to Java Programming Unit 3. Currently, we are discussing Chapter 3 interfaces of this Unit 3. And we know that this interfaces chapter is composed in 3 videos: video 10, video 11, and video 12. And currently, we are at last video of this chapter, interfaces. And these are the topics going to be discussed in this video. Inheritance of interfaces, default methods allowed in interface. The same way, static methods also allowed. Some functional interfaces can create using interfaces in Java programs, and functional interface annotation. And these are the topics we are going to discuss now, one by one. What is the first one? Inheritance of interfaces. And here it is. One interface can inherit another by use of the keyword extends. Up to now, about these interfaces, we learned how to inherit the properties or how to implement the interfaces by the different classes. And now we are going to see the interface can inherit another interface by using the keyword called extends. And we are familiar with this keyword extends and implementing or extending the properties of one class to another class. Nothing but creating class hierarchy for achieving the inheritance among the classes. And in the same way here, so whenever one interface going to inherit the properties of existing inheritance, so that is the concept called inheritance of interfaces. Now coming to the second one, the syntax of this one same as for inheriting classes. And we are familiar with this concept, inheriting classes. When a class implements an interface that inherits another interface, it must provide implementations for all methods. This is already known by us because when a class implements an interface, whatever the methods defined in that interface must be implemented by that class, right? So this is called interface inheritance chain, right? Then coming to here, in addition to that, we learned this up to this one, but here is the concept of when one class implements one existing interface that is already inheriting another interface. So this is the thing we are going to see here. So consider that interface 1 and interface 2, and this interface is extending the properties of this one, interface 1. Wherever our class is going to implement this inheritance 2, the condition is that the same condition we followed up to now. When the class implements inheritance, this class must and should implement all the methods defined in the interface. Whereas here, some inheritance is achieved among these interfaces. Whenever this class extending these properties of interface I2, so this class must and should implement all the methods defined in this interface 1 and as well as interface 2. Okay, got it? Here it is one simple example to illustrate the point we just now covered. So here in this program, one interface is defined, that is interface A, and method 1 is defined in it. And whereas another interface that is called B, and this interface B is extending the interface A. So this is the thing we are going to discuss in this inheritance of interfaces. So this point is clear. Whereas coming to this my class, okay, my class is the name of the class in which implementing the properties of interface B, interface B. Whereas this class must be implement all the methods defined in interface A and interface B. Why? Because some inheritance is achieved among this between interface A and B. So then the class which implements this interface B and B having some inheritance relation with A. So this class must be implement all the methods defined in the both the interfaces. That is in interface A method 1 and in interface B method 2. And these two methods should be implemented in the class, right? So this is very important point to be learned here. While we are implementing or getting the concept inheritance using interfaces. Coming to the main class, the class name is test and main method. And I'm creating an object of my class. Here this program, it is instantiation of this my class, right? And using this object, we are trying to call this method 1 and method 2 defined in this class. So method 1 we invoke by this statement of execution and method 2 invoked to the reply of this statement. And when these two methods invoked and executed, and the implementation part of this method 1 is, it is implement method 1, implement method 2. Both the statement will display on the output screen at the console. Understood? Then coming to the execution part of this one, just go to the program file, test. So coming to this to for better understanding you that how it executes practically the concept we just learned interface A, interface B extending properties of interface C. And go to console. Remember the file name is test. Go to console and try to execute this file using command javac test, right? Javac test java. Got it? No files, no errors. Then execute this one. And this is the output. Implement method 1, implement method 2. Both the methods are invoked by the class object because the methods are implemented by the class called myClass. Clear? Then the next topic is default methods in interfaces. And before going to that one, I'm just giving the example of this inheritance of interfaces. And you can do some more examples for better practice of this achieving inheritance among the interfaces. Okay. Then default methods in interfaces. Generally in interfaces, only one method is allowed to, not only that one, only abstract methods allowed to define. But whereas in after Java 8, since Java 8, Java supporting this default methods in interfaces. You will see how this can be achieved. And coming to here, default methods in interface. From Java 8, we can have methods, we can have method body. See, this one is important. Till now, we know that interface is only for defining abstract methods without body of the method. But here it is allowed in Java 8 from onwards. You can have method body in the interface, but we need to make it as default method and declare that method as a default. See the example to understand this one. Is it executing and working or not? Currently, we are studying the curriculum given by R19 regulations J&UK Kakinada, and completely it is based on 8th edition, right? Next one. Coming to here, default methods in interface. Here is simple example. consider that here, this interface drawable is an interface, and draw is a method without body by using this end of this function definition, method definition, prototype with semicolon, end with semicolon. That it means this method body is not allowed to define here, right? This is abstract method. But whereas if you observe, there is one method defined in this interface with name called MSG with the type void. But also in addition to this void and message in function definition, this method definition is precedes with keyword called default. So this default keyword defines and declares this method, define this method as a default method of this interface drawable. So this feature is added for Java from Java 8 version. Okay. And this method body, message body, simply displaying this is a default method defined in interface. Whereas coming to the class rectangle, here it is a class rectangle, implementing this drawable interface, and must and should implement this draw method, right? Because it is an abstract method defined in the interface. So this draw method must be implemented on its own by the class rectangle. Okay. Then coming to the main class, inside of this main method, we just created one reference to the interface. It is called reference to interface drawable, and assigned instance of this rectangular class. And we know this type of declaration of this reference variable of interface to refer the objects of that class implements this interface drawable, right? And this is concept we already covered how this and why this in the previous video very well. And using this reference variable of the interface, we can call the method defined or implemented in the class, which implements this interface as it is allowed. It's a valid statement. When it is executed, this method will display on the screen like this, right? Next one. I'm using this reference variable D of this interface drawable, and this reference variable can access the methods defined in the interface. Simply we can call d.msg, as this msg will invoke by this reference variable of the interface. Then it simply display that message on the screen as this default method. So it is allowed and it is possible, right? Until now we just not accepting any normal methods in interface like a class, but whereas we can allow to define some methods with default keyword. Okay. Then coming to execution part here, go to file. Remember this file name as class name test9 and file name test9. So the same program copied here into this file, and we are trying to execute this using command prompt by the command executions like Java C. Then go to Java C test9.java. No errors, and execute test9 class 5. So drawable, drawing rectangle and default method. Drawing rectangle and default method. Got it? Both methods, that it is abstract method of the interface and as well as the default method of the interface, both are invoked, and this drawing rectangle method is implemented by class. Got it? Drawing rectangle, default method, output execution. And coming to the next one, static methods also allowed to define in interfaces like this default methods. Go and see this. Since Java 8, you can have static methods in interface. As it is also allowed. Go to the example part. So here it is, drawable interface, draw method, One method is there for calculating cube of the given integer value. This is a one method defined in drawable interface and taking one argument that is type integer and it calculating the cube of that given integer value. And we define this method as a static method, in the interface. So this is the behavior of this interface drawable. And coming to the class which implements this drawable interface, that is called rectangle. And the method abstract method must and should be implemented, and we know this one. And drawable rectangle implemented, this method implemented, right? And coming to the main class and void main method, we are creating that reference variable of this interface and refer to the instance of this rectangular class. And we can call d.draw valid and executed, and this method will display on the screen. But whereas this cube method cannot be referred by this reference variable or any object of this one or anything. Why? Because static method can call without creating an object, and we know this concept and point discussed in the classes concepts also. But coming to here, we can access these static methods by interface name. In the classes point of view, static methods defined in any class can be accessed directly the class name, not by object or instance of that class. So here we can call this cube method by passing an integer value by using this interface name followed by dot operator. This is the way you have to call the static methods of any class or interface. So specifying the name of the interface or a class and using dot operator and method name is any parameter less, then this method can invoke. And when it is going to execute, it simply display the value as 3 cube, that is 27 on the screen. Got it? And go to the example. And these are the examples for simulating you that the features added to Java from Java 8 edition or version of 8. So you can practice some more examples for better practice of these concepts. So Java 10, test 10 is a file name, draw method cube, and it is defined as static. And we are calling that cube method through the interface name and dot operator and passing 3 as a parameter, right? Go and execute this one. So Java 10 is the file name, Java C test 10.java, the file name, and executing. And compiling this one, no errors. Run this one. So drawing rectangle and 27. So are you getting or understanding it or not? So very simple programs. We are here to understand the concept well. And go to the PPT now. The next one. So next, the concept is functional interfaces. It is also a new feature added to Java, and see what it happens and how it is going to implement. An interface that contains exactly one abstract method is known as functional interface. That's right now. Till now, we've seen many examples of this interfaces concepts, and generally we followed the same concept there. Only one abstract method defined in the interface. Generally, you are allowed to create many abstract methods in an interface declared. But here, specifically this functional interface point of view, exactly one abstract method is allowed. And that it means when you are creating, okay, when we define only one abstract method, and only one function to be performed by that interface. So when we like to call that interface as a functional interface, it can have any number of default methods, any number of static methods, but can contain only one abstract method. Then only we call that methods are that interfaces as functional interfaces. Then okay, right? It can also declare methods of object class. And in the last video, we seen this one point about an interface can have the methods defaultly defined in the object class also. Object class is a universal superclass to all the Java classes defined in your programs or projects. So if this object class contains some predefined methods, those also you can also declare into the interfaces, even though that is a functional interface. And functional interface is also known as single abstract method interfaces. That it is true. Single abstract method interface is also known as functional interface. It is a new feature in Java which helps to achieve functional programming approach. Functional programming, nothing but the functional programming function means nothing but a method and which contains some set of instructions to perform particular operation related to a task, right? The same way, we can achieve this one by using functional interfaces. So here it is one simple example to understand these functional interfaces. So you can include the statement or not, doesn't matter of compiler, it ignores sometime and it feels that it is a functional interface. We are just giving that intimation to that it is a functional interface, right? So keyword interface followed by interface name and only one method of abstract. Only one abstract allowed. In addition to this one abstract method, we can define many default methods or static methods and only object method, object class methods also we can allow the final variable. But only one abstract method should be present in the interface. Then only we call that as a functional interface. Next one, the class which implements this interface must and should implement this one. This is a predefined default process. As it is simply, and it is a function expecting one string argument, and we pass it the string argument and simply displaying on the screen. This is the behavior of this method implemented by this class test level, right? And coming to the main function of this class, we just created the instance of this test class. So remember test 11 class, test 11 class, and x is an object of this one. Now you can say x dot say is a method you can directly call or invoke through the class objects, and hello there is the string argument passed to this method say when it is invoked using the object of this test 11 class. Okay, got it? Then go to execution part of this one. Test 11, yeah, it is clearly given. Okay, right? So are you observing this one, right? The statement is doesn't matter here. Okay. Next one. Go to console for execution. So Java 11, test 11, sorry. Test 11.java. Compile this one. No errors. And execute this one. And that same method invoked and executed. And this is the parameter we pass it to that same method. And the same message are displaying on the screen. So this is the execution part of this functional interface simple example program. Next one, Java provides predefined functional interfaces to deal with functional programming by using lambda and method references. So we'll discuss this one. But coming to here, this Java provides after Java 8, some functional interfaces are predefined functional interfaces are defined. And you also define your own custom functional interfaces and user defined functional interfaces defining also allowed. And this is the link for some predefined functional interfaces. I will show you. Yeah, coming to here, Java predefined functional interfaces, and these are the functional interfaces predefined to deal with functional programming. And these are the some different types of interfaces and functions defined predefined, and we can use those operations like first one, by consumer. It represents an operation that accepts two input arguments and return no results. Like this, these are the some types of functional interfaces are already defined, and each one having its own representation and usage. And in real time problem solving, you may use these things for solving or make your program simple and faster execution by using this one also. Okay, got it. Next one, coming to that example point of view about this one specifically, lambda and the method references. So here it is a Java program to demonstrate lambda expressions to implement a user-defined functional interface. That it means, so you are allowed to create some lambda expressions and some user-defined functional interfaces. Both are covered here. So coming to here, one functional interface is declared in my program. So that is a square. So interface square. So inside of this one, I have an abstract method called calculate of type integer and taking one integer argument. The integer argument given to this calculate method, it simply calculates the square of this given integer value. And this is a square is an interface and having only one abstract method. So this is considered as a functional interface. And whereas coming to this test class, test 12 class, just having this class interface and a square. Okay, here. So in this test 12, just taking one instance variable into this class scope, that is a equal to 5. And one lambda expression is defined to calculate the square. So square is a interface name, and it created one reference variable of this one. And this reference variable and defining that calculate method of square, and in parentheses we are giving an integer value, and that integer value is square multiplying with that number itself, and this implication relation specifying this number whatever given to this square interface or defined method calculates, and this number is calculated the square, and this reference is to execute this lambda expression. Now this through this reference variable we can call this method to execute this lambda expression for given integer value. So here one integer variable is defined for why, because this expression returns something value. It returns something value of this calculation. So to hold that one, and simply this calculate method returns some result value. To hold that one we need an integer. Why? Because this calculate method defined in interface as integer type. So definitely it returns some integer value. So that's why we need an integer with integer variable. And we use how this calculate method can be invoked. Here this method invoked through that reference variable of this square interface. As it is allowed, S can call this method, but that is not defined in interface and as well as in main. But here that method is defined as lambda expression in the class by the class. So here s dot calculate by passing some value, that is instance variable 5. So here it is 5 is given to here, and it simply execute this lambda expression, and it gives returns value square of this 5, that is 25. So we have window, just go and execute this one. So this is the same program we have taken. Interface square, calculate method, test 12 class, and this is lambda expression, and this is calling to this calculate method through reference of this square interface. Go to console program, simply. So Java C test12.java, compile it, no errors, then execute. So 25 is executed. You understand it or not? So very simple to understand. We can use these functional interfaces to create something, implementation of some lambda expressions that implement a user-defined functional interface, right? And next one, functional interface annotation. So this is also sometimes we need to keep in mind that when we are working with this functional interfaces. So functional interface annotation, it is used to ensure that functional interface cannot have more than one abstract method. This is the point clear. In case more than one abstract methods are present, the compiler flags unexpected functional interface annotation message on the screen. It gives an error. And when we call the functional interface as invalid declaration, right? Or specifically in the inheritance point of view, when any interface extending any interface, that is considered as a functional interface. You see that a functional interface can extend another interface only when it doesn't have any abstract method. It doesn't have any abstract method. This is the point clear using the example given here. See here, one interface is called sayable and one abstract method, that is say and this. So this is clear. One abstract method is defined in sayable interface. Whenever another interface called doable is trying to extend the properties of this sayable, then the functional interface annotation will active of checking these interfaces with the defined abstract methods in both the interfaces. So doable is not a functional interface. Why? Because it having one method defined in it, that is void do it. And when this interface doable extend the properties of sayable, then this doable interface can be having the methods both say method and do it method, but it completely violating the concept of functional interfaces. So whenever this doable wants to extend and no any abstract method not be defined in it. That is the point, this last one. A functional interface can extend another interface only when it does not have any abstract method. When it has one abstract method, then after extending the properties, it can able to have both abstract method, two abstract method, that is say and do it. It is completely violation of the property called functional interface. So it completely gives compile error at the compile time. When we are implementing inheritance or extending the properties of one interface by another interface, this point need to be remembered. Go to the checking of this one in the program point of view. Coming to 13, fresh 13. So here it is taking sayable, say method, and doable and with one another abstract method. So two abstract methods defined for this interface inheritance among these two interfaces, right? Then go to the console of execution. Test Java C test 13.java. So see here it gives annotation error, unexpected functional interface annotation. Doable is not a functional interface because it has already one abstract method in it, and it's trying to extend the stable interface that is already having another abstract method. Both they cannot allow. So multiple non-overriding abstract method found in interface doable. That's why it is an error. So when we are achieving inheritance among these functional interfaces, the condition need to be verified. Okay. Very simple one. And all these examples are very simple to understand the concept well. These are the references. All the examples we have taken from this Java T-point reference for giving you the most simple understanding. Okay.